So, I think we should get going, otherwise we'll be late again, or I'll be chased out of this room and we don't finish the lecture as usual. So let's change that pattern a bit by starting seemingly early. We'll see how that goes. Anyway, so last session, most of you continued hopefully with the lab and finished up your setup. There's no Mac people here. So apparently the Mac crowd solved the issue of not having the triangle displayed, and it could be related to, or could be similar perhaps for some of the exotic Linux derivatives. So it may be worthwhile talking to each other because there seem to be some specifics in the shaders that are responsible for that purpose. I further talked with Simon Myrish about past these experiences, and I said generally open source drivers are not necessarily desirable for development. The reason is mostly that it's super hard to debug, in a sense that you don't know if it's the driver or your misguided programming activities that lead you to those artifacts or missing elements or geometric oddities or whatever else, because open source drivers apparently are always or mostly incomplete with respect to the implementation.
So this is first lecture for the mobile research class, and the class is a little bit different to your typical setup, and we have two courses, two specialization courses. One is in mobile and distributed tech, and one is in games. Who of you is doing the games also with Simon? So those of you who are doing both, you will kind of experience two styles of debating. In Simon's course, you will have to speak and present your arguments in a verbal form. In this course, you will be asked to do the same, but in written form. So this course focuses on argumenting and arguing for a particular case or particular point of view using a written format, right? So in this course, you will be asked to write short essays and then counter-argue somebody else's point by writing a short essay, right? So you either write your own point and kind of argue for it, and defend it, or you will be arguing against somebody else's point by pointing out some weak spots or some illogical arguments, or bringing up evidence which kind of doesn't support the claim that somebody else is making, okay? So we do that using kind of a in-house built tool, and you kind of write the essays in a, just textual format. And then other students can see that and counter-argue for them, okay? So we have sort of three forms of expression. One is the essay itself. One is the counter-argument for somebody else's essay, saying, okay, you're wrong because. And then the third one is just a review, kind of a neutral review of the quality of the original essay. We're not reviewing the counter-arguments, but we will be reviewing the original essays. The essays don't have to be very long, but you have to make a point. So you have to describe what your point is and bring some evidence kind of supporting the point. What is the theme? Well, the theme is quite open, right? So in this course, we're covering mobile technology, distributed technology, cloud technology, wearables, anything to do with sort of a modern, modern technologies, broadly speaking, right? So I have sort of an empty page, and if you kind of think for a moment, what the mobile development, what the mobile and cloud developments kind of are, we can list the topics that are sort of the broad categorization of the space that we're dealing with, okay? So the first exercise is to have some sort of a high-level points of what it is that we can potentially discuss in this course, right? To give you an example, a mobile cloud connectivity and efficiency of where to run some processes on the cloud and when to run some processes in the mobile is one of those topics, right? So for example, performance of cloud versus mobile computing is potentially one of the topics. So take a few minutes and think what are the other topics that we can discuss. Okay. So then once we do that, once we have a kind of a categories, what we will do is we will search for papers which kind of are fitting within those categories. And we will look at problems which people are dealing with, okay? Again, it's slightly different to the way specialization in games works because the papers and the topics are kind of given to you, okay? For this course, I want those two courses to be slightly different, right? So we don't repeat the same thing. So for like if a student is taking both courses, you will not have the same sort of pattern. You will have complementary patterns, right? So in this course, we first try to identify the topics jointly as a group, and then we will kind of search and fill in the papers which fit in recent innovations which fit in for those topics. What we will do next is we will pick, each of you will pick 3 topics, different ones. We try to mix so then the topics don't kind of repeat. And you will write 3 essays within those topics saying, okay, I believe this is true, okay? And then you will do the same for the counter argument. So each of you will write 6 pieces. It will be 3 essays, 1 counter argument, and 2 reviews, okay? So in total, you will write about 25 pages of stuff with those 6 things, right? So in games, if you're doing games, you will have to write a report, which will again be between 15 to 25 pages long. Here you will write the same thing, but on 6 different things, right? So you'll write much shorter pieces, but in total you will kind of write similar amount. And you will not argue verbally. You will only argue in writing, okay? Why? Okay, we are kind of investigating or trying to learn how to prepare kind of a good written argument and how to defend it and how to read papers and see weak spots, okay? So some papers which I will suggest for some of the topics will be kind of faulty by default, okay? It's sort of easy or maybe not easy to see why the conclusions are not logically derived from the premises the paper claims to have, right? So kind of being able to spot that is kind of one skill, and then being able to formulate your own arguments and then derive kind of conclusions from it is another skill. It will come really handy next year and also when you're writing your thesis to sort of formulate your argumentation this way, right? Any questions so far? Great, so 5 minutes, Google, search, check what topics we can specify which would fit for that course, okay? For now, we just, let's say I put 1, and then we see how it goes. All right, so we have 1, mobile cloud interoperability and performance. And then think and propose other areas or high-level topics that we can group under a single umbrella for further kind of investigations. Of course, this exercise is a little bit hand-wavy because you can do it in different ways, right? You can pick different categories, different dimensions of how you're gonna divide the space, right? We can say, okay, something to do with cloud and something to do with mobile. It's one kind of categorization. We can do something to do with security, something to do with scalability, something to do with mobility, right? You can pick different dimensions and then organize things along those dimensions. So we're not doing like a proper taxonomy. We're just sort of highlighting general topics that kind of occur within the space to have some sort of map, but it doesn't have to be a properly defined taxonomy, right? It's sort of more of a mind map.
It could be something like scalability or scalability. Like when this communication cost starts hurting the scalability of the system, so that you're scaling up a cloud system, and then they have to communicate, and that sort of starts being a bottleneck.
Okay.
Could that be a theme or?
Yep, it can. So let's say scalability, billing, and performance. Right, so that's fine. It overlaps a little bit with the first one, right? So you see this one more from the cost perspective, right? Or not necessarily?
No, I'm thinking in the communication part, sort of
that
the nodes have to be communicating with each other. And when does that start hurting the actual process, so that you should scale down?
Yeah, so it's more like Yep, good. So then it doesn't really. So the first one is more what you're supposed to do on the cloud and what you're supposed to do on the thin devices on the client side, and how you balance the performance this way. This one is more focusing on the actual communication. Yeah, that's fine. Yep. Yeah, we can add infrastructure here. Yeah, what else? So those two are quite narrow, right? They could be under the same umbrella, so to speak. You can say, okay, we have, so if I say scalability and performance, those two would kind of fit under, right? So what else? Yeah?
Like battery or energy management?
Energy management, perfect. Yep, so on some action and it's one of the topics, but there is more under the energy umbrella, right? We did have discussed last year some of the techniques for conserving energy, some of the software development practices of how to make the battery lasting longer. There were papers, for example, from the energy consumption, whether doing something on the mobile is better than shifting the data to the cloud, doing it in the cloud and shifting the results back. And you have to trade off the battery consumption for the communication versus the battery consumptions for the processing, right? If doing the processing is cheaper on the mobile, you should do it on the mobile. But if doing the processing drains your battery more than sending the data over, you should send the data over, right? So it was not zero-sum game. It was just shifting, like, it was assuming that the cloud energy comes for free, sort of. It's not affecting the battery, right? In reality, it's a zero-sum game. You cannot use less energy than it's needed. In fact, by sending it over there, doing it there, and sending it back, you're using more energy than just doing it on the phone. But you're not draining the battery, right? So the battery will last longer. So we had some discussions about that last year. Yep, that's a good one. What else?
One is wearables and potential security risks, since they track more of your personal aspects.
Perfect. So we can say wearables in general, and then under the wearables, security, threats, and risks. Could also be privacy, maybe. Right? What else?
User interface.
Perfect. So UX, UI, in general, you could do it sort of mobile specific, but you can do it for other use cases, like how you do UX, UI on wearables, how you deal with the watch UIs. So we did have some papers last year about that. We were discussing, for example, various technologies for assisting typing, right? So there was a paper which we discussed last year. Is it more efficient to have gestures which are editable shortcuts, or whether doing everything the way we kind of do it right now is more efficient, right? So like, let's say you are editing a text message or an email on the mobile phone. So you're kind of editing it, and then you need to delete the word. So you have to place the cursor at the end of the word and press delete a few times, to delete it. And then when you want to do something else, you have to like click, like you need to fix a letter somewhere. Again, you have to find the place, put the cursor there, and so on. So it's a little bit tedious and a little bit time consuming to do that manually, but you can have gestures which are like delete the word, right? So no matter where the cursor is on that word, you can do the gesture and the word just disappears, right? So you can have some help in kind of editing your text. And there was some research done of which one is more efficient. Of course, there is a learning curve, so the users have to learn the gestures, right? So the paper was a little bit, it wasn't perfect because the people, like it's kind of comparing apples and oranges. Like people are quite skilled in placing the cursors and kind of doing the normal thing. If they have to use the gestures, they have to look up, okay, what the gesture was, right? So they had some cards which were kind of showing them what the gesture was to kind of use it. But that's kind of imperfect. It sort of favors the normal users a little bit more. You could have an experiment where you let the users learn the gestures and then become more efficient with them, and then compare the normal users with those. But then you have the learning curve issue, right? So it is kind of hard. So UX, UI usually is quite hard to get kind of conclusive remarks. You have to really think through how you do structure experiments. But yeah, so we did something like that. So it was kind of in the context of text editing, but that's really specific, right? It's like third level of specificity. So what else? What else on the high level we can put, and what else we can fit into various things that we have?
Could we put UI and UX specifically for VR?
Yes, we can. So you can have VR specific. What other wearables you using? I'm using a smartwatch, which tracks my activities and my heart rate and my temperature. And when I go for running or swimming, I use like a chest strap also, which monitors more detailed the heart rate. What other wearables you know about or you use? Yep.
Garmin.
Yep, you have a Garmin as well. Any of you use like the sleep bands for EEG? There are some smart vests which are kind of doing what the watches are doing, but they know a little bit more because they have more sensors built in. There are some technologies where you can use in a car, so you can plug in an app or a device which monitors, fuel consumption and acceleration and different things related to your car. Yeah, it's not really wearable. It's like wearable for a car. Okay, so what else? What else do you think we can place there? what would interest you? Like, what would you like to kind of read upon and learn more? Or what was recently on the news, or, you know? Security is a big one. So we have security under wearables, but, you know, security for mobiles is kind of relevant too, right? So we could elevate that to, actually we could elevate both to a top level category. And say do it this way, right? Yesterday there was an article about the patching of the Meltdown and Spectre vulnerabilities on the mobile platforms, and the situation is terrible because they are basically not doing it. So Google was doing it for the Nexus line of phones, but it only affects the Nexus phones with the latest security patch from January the 5th. All the other Android platforms are still kind of vulnerable to exploits using the Meltdown and Spectre. Yeah.
Possible to look at performance impact as a result of that?
Of some trade-offs between security and performance, or
yeah.
So I would put it here, right? So I would say performance, scalability, and security. Yeah. Yeah. So that's true. Most of the patches have to hinder the performance, unfortunately, but yeah. There was an interesting talk I've seen towards the end of last year, which was about the power button. So, you know, the power button of the old PCs was a physical switch, which was turning off the transformer of the electricity. So you could basically flip the switch and the power was cut off to your motherboard, right? So it was a physical connection between the switch and the transformer, which was using the you know, the variable current to the stable current. So nowadays, this physical switch doesn't exist. It's all software driven, right? So your power buttons are kind of software driven to a point where sometimes it's like the power management system is so complicated that it's like a mini OS, right? It can have its own exploits and its own security flaws. So we sort of see like software going everywhere where it can, even to places which used to be physical things and physical kind of devices, right? It's the same with tickets. Like, you know, tickets used to be a piece of paper. You go to a concert or to a cinema and you have a piece of paper. But it is kind of disappearing. Like you see just, you know, you go to Trondheim and you have this app which gives you a ticket on the phone and that's it. You don't have anything physical anymore, right? So this kind of a transformation of physical things into software is kind of happening, and I think it is relevant to the course too, but it sort of doesn't really, like it doesn't exist as a kind of a theme, right? Like we see that's happening, this kind of transformation, but it's kind of hard to capture it as a sort of a theme. But you know, sometimes you see articles like software is eating the world, things like this, right? They a little bit like conspiracy theory or something that, you know, but it's not about that. It's about it's about convenience, and it's about control, and about automation, right? If tickets are physical items, then humans have to somehow print it. Something, you know, physical has to happen. But if something is being put into software, then it's so much easier to automate it and to control it and to kind of manage that. So I would put some sort of a theme at the top, which is let's say software replacing physical artifacts. But you know what I'm getting at here, right? And it is kind of relevant because mobile allowed a lot of those things to happen, right? So, you know, payments, like how often do you really use cash these days? Very little. You have mobile payments, you have debit cards and so on. You have kind of electronic payments. And in developed countries like in Norway, I actually almost never touch cash. I could, it's fine, and a lot of people do for privacy reasons and so on, right? But you don't have to. It has been sort of replaced to a point where some countries are considering like completely getting rid of cash, right? So yeah, I mean, the topic about getting rid of cash is not a technology question. It's more of an ethical and moral and political question, right? Because technologically we can do that. But a lot of people would say, yeah, but you know, how about our privacy? How about our right to spend money and nobody knows what we spent it on, right? Cash gives you that ability. And then if we all go to only electronic payments, then someone tracks everything, right? Someone knows who paid for what. And then you lose this ability for paying anonymously. But, you know, maybe with blockchain technology or with some modern cryptocurrencies, you can still have that, right? It's electronic and anonymous, right? So, yeah. Yeah, but payments and crypto is, again, a kind of a different topic, right? Yeah.
But I think so I was thinking about the healthcare and the wearable sensors.
Yep, that's a good one. We had that last year as well. So so let's call it eHealth, mHealth, pHealth. You know all those acronyms? So what's eHealth? Electronic health records. It's all about making records electronic, right? I actually don't know how it is in Norway. I don't use doctors that much, but in New Zealand, the health records were kept in a file. It was like a folder, and your GP had that folder, and you go there, and they have this kind of a printed folder of all the visits and all the vaccinations and all things that happened to you. And then if you want to change the GP, you go to your GP and you say, I will be changing the GP, so they will give you that folder, you take it, and you take it to a new GP, right? And then if you go to a hospital, the hospital calls your GP, and the GP kind of gives the folder to the doctor in a hospital, right? So it was actually like a physical piece of documentation. And it is, I think it's similar in Poland too, right? So there is some sort of a physical thing that you carry between doctors. So for example, you go to do your blood test, you get the blood test done, they will give you a kind of results, the printed raw data. You take it, and then you go to a doctor, you give it to a doctor, and then the doctor will give you the sort of summary, right? Yeah, so eHealth is all about, okay, let's get rid of paper, let's make everything electronic, and let's make those health records being exchanged between the stakeholders in a safe and secure manner, right? mHealth. So mobile health, it's all about wearables and all. It's not actually about wearables. The pHealth is more about wearables. mHealth is more about being able to communicate with the doctor over distance, right? So like you have, you are sick, and instead of you going physically to a doctor, you can kind of use technology to assist your yeah, so the doctor can do some assessment without being with you, right? Also, for surgery, assisted surgery, or you have a hospital or you have a doctor in some remote location, and the doctor needs some assistance or needs some help or expertise, then from the big hospital in a big city, there is video and audio communication channels that allow this kind of a help to be available in remote locations. And then the P-Health is personalized health. So this one is about wearables and about making the healthcare more personalized. Okay, so normally, again, it's kind of a complicated topic. So normally you have some general guidelines and general prescriptions for the whole population, right? So you say if you have such and such symptoms, majority of the population have that disease or that problem, therefore that's your, that's the kind of resulting diagnosis, right? But if you using only those kind of generalized approximations, you will be wrong fraction of the time. Sometimes that fraction is very small, sometimes that fraction is quite big, because the variance in the population is quite big, right? So if you have flu-like symptoms, you might have flu, but if you have a certain history of certain diseases, your symptoms may look like flu, but you may actually have something else. And if you're being considered in a kind of general population, the diagnosis will be, okay, that's flu, right? But if you consider in the history of your own diseases, then it may be that it's clear that it's not flu, it's something else, right? But to do that, we have to have sort of a knowledge and histories per individual. And P-Health is kind of trying to achieve that. You can kind of have your personalized track record of different things that happen to you, of your hereditary traits from your ancestors and so on. And then the doctor analyzing your kind of case, instead of taking knowledge from those generalized knowledge bases that we have about the populations, it's kind of doing it on per individual basis, and then may have much more accurate prediction of what works and what doesn't. It doesn't mean we don't do it now, neither. I mean, we are. Like if, like my father, for example, is, he cannot take aspirin because then it thins his blood too much and he has problems. So it's kind of a known case. It's kind of specific for him, but not really just for one person in the world. Like there is a group of people who are, allergic to aspirin and they cannot take it, right? So doctors know that case, right? But they might be, those groupings might be smaller and smaller and smaller, right? So you might be kind of individual because of your genetic makeup and your kind of disease history. It might be kind of helpful for doctors to know that. So P-Health is trying to analyze how we can bring technology to make it possible, right? So all the health records, mobile health or P-Health topics are definitely there. So we can say sort of health in general. And then again, we can have, wearables, and we can have security, right? Or privacy as a subtopics. So you see, we already can have multiple taxonomies, right? We can put health under wearables here, right? Or we can put focus on health in the context of wearables, right? So it's sort of it's not clear, right? If you're doing a proper taxonomy, you kind of define like a Venn diagram kind of thing where things are kind of self-contained. Here it's a little bit messy, but it kind of gives us the angle, right? So for example, if you're talking about health, then you can dive more into the usage of wearables, but your focus is on health. If you're talking about wearables, you can use health as an example domain, but you're not focusing on health, you're focusing on the wearables, right? So for example, if we do, I don't know, let's say activity tracking, then we are focusing on technology which supports activity tracking. It can be for sport, it can be for health, it can be for anything, right? Whereas if we did here activity tracking, it's with a specific purpose for health, right? So What else? Yeah.
Developing from targeting multiple operating systems and versions.
Can you repeat that?
Developing and targeting multiple operating systems and versions.
So targeted for what?
I'm thinking about Android. There are very many different versions of it. Operating system fragmentation.
Yeah. Okay. Okay. Yep. So let's put it a bit more up. It's more technology centric. So it's a good point. What would be the umbrella category for that? What would be something that this became kind of a part of?
Operating system support.
Yeah. So let's say platforms, and then say right. So those are sort of keywords. And then you have other topics related to that. Would that be correct? Yeah. Platforms for mobile, Internet of Things, cloud, in general, platforms. Yep.
Memory usage. So like how, like the Facebook app is insanely huge, and same with like the LinkedIn app. I don't see the reason for being as big as they are, seeing as the programs should actually be relatively simplistic.
Yep. So we could have this one is a good one. We could have it under some scalability and performance issues, right? Or we could have something which we can call limited resources computing, and look into the memory usage from that point of view, right? In the Facebook app point of view, it's not really a limited resource device because you have a lot of RAM and so on your mobile, but the problems are kind of similar to the ones which you could, for example, use for IoT, right? So I would kind of put it under both. You can even have that topic being dealt under the memory, under the energy management from that point of view as well, right? So the memory usage is kind of spanning multiple things. In itself, it could be sort of a top level one, right? But we can retrofit it under limited resource computing, scalability and performance, or battery. Yeah, we discussed it yesterday in the mobile course, right? Because I said that, on the Android or iOS platform, the operating system is doing life cycle based on what is happening with the device, right? I don't actually have my mobile here, but let's say this is a mobile phone, right? So if I have an activity on the front screen, which I'm using, let's say a game, and I stopped it and I put it into a background, and now I have a different activity on front, right? So the operating system is seeing, okay, there is a game in the background which is currently not being run. It's paused. The user is not using it. The user was not using it for an hour. So we will just wipe it, right? We just kill it from memory, right? And when the user picks it to be loaded again, we will have to redo it from scratch, right? We will have to allocate all the resources, all the assets, and so on, right? So why would the operating system do that? Well, the operating system may do that because it's running out of RAM, right? The front running application needs more RAM, and it has to release some of the resources which are currently not used. So it says, okay, that app goes, right? But the operating system can also do it because stuff that is kept in RAM is using battery, right? So there was a question, okay, how much effect it has to have, let's say, 8 gig of RAM being all utilized, and having only 1 gig of RAM being utilized and the rest being free, right, on the memory consumption? And it's a kind of a valid question, right? And you can investigate that. You can have an experiment and measure how much more you're draining the battery if you're occupying all 8 gig of RAM, and how much you're draining if you're only occupying 1 gig, and you can kind of turn off the chips which are not being used, right? Can you do that on the mobile platform, right? You can check, okay, what are the hardware capabilities? For example, on the high performance computing, most systems are able to turn off the particular DIMMs of RAM that you have on the motherboard, right? Why do you think they are able to do that? So you have a rack, you've mounted a server, it has, I don't know, 128 gig of RAM, it has 24 slots with the DIMMs being put there, and the BIOS can turn off power to any of the slots at will. Like, you can program it so you can tell the operating system to turn off the power to particular RAM. Why would you have that?
Save electricity. Yeah.
Save electricity, that's...
heat generation, perhaps?
Say it again?
Heat generation.
So, save electricity and heat. Those are good points, but those are not why we have that. Why we actually have that. So they are used for saving energy now, and they are used for saving, you know, if they are not used, you can turn them off. But why we have it in the first place? Why we had that in the first place? What do you think? What was the reason why we designed system to be able to do that? We did that in the era where we didn't care about the heat and energy yet that much. I mean, we cared, but
technically, it's less things to care about, so address spacing and stuff.
yeah, I think kind of more fundamentally. So if I have a server, let's say, you know, telecom server running in some sort of distribution center, it's deployed. What can go wrong? Faults can happen, right? So, you know, RAM can become faulty and it will need to be replaced, right? So then what would I do? Do I shut down the server? Well, I don't want to do that. I don't want to shut down the server, right? So yes, so I basically will turn off the RAM which is faulty, remove it, put the new one in, and turn it on again, right? While the system continues to run as before, right? I'm not shutting down the system, right? So those sort of rack mountable servers, they are kind of a marvel of technology to run forever, right? They usually have redundant power supplies. So you have multiple power supplies on a single server. So if one fails, it automatically switches to the one which is not faulty, and you can replace the one which is faulty, right? They usually have redundant CPU units. So not only multi-core, but you have multiple CPUs, right? So if one of the modules becomes faulty, one is continually to run, you replace the one which is faulty. RAM, it's the same, right? Because you have multiple power supplies, it's really cool because, you know, if I have a rack or a server plugged into this power point here, right? Then I can kind of plug it to this one with the other one, unplug that one, and kind of walk with it, right? So I can keep it running and walk across building, right? And it never shuts down because I can keep unplugging it and plugging it, right? You cannot do it with your home PC because you have only one power transformer, right? So we did that. So we had to move, you know, our rack from one office to the other without shutting it down, and we just did that, right? So why you do that? Well, you have all those user level agreements, right? If you say I'm guaranteeing 99.999% of run uptime, well, you know, it's really hard to do that if you don't have all those measures in, right? Because bad things happen. So the main reason here is redundancy, right? So we have ability to turn off the the RAM because we want to be able to replace it on the fly while the system is running. Okay, so why we got sidetracked to this? What was your original question?
Well, memory usage.
Yeah, memory usage.
So I was thinking of it more like negatively, like why is everyone just wasting it away?
Yeah.
Like the Facebook, for instance, the Facebook app probably doesn't need to be like 500 megs, whatever. And same with the LinkedIn app was insanely huge, and like basically what you're actually doing is just reading a bunch of stuff from file.
Yep.
Same with Twitter, that's basically just like a file being appended to all the time. Why is that so big?
Yeah, so what I would say, what we could do is we could have a category. So we could put it really under like a software development practices in the context of mobile, cloud, IoT, and so on, right? So, you know, I don't know why this particular app is that wasteful, but what usually happens is, you know, you are a big company and you sort of are doing something for a particular business case, right? And whether you're using more RAM or less RAM is irrelevant to you.
Yeah.
And it's cheaper for you to use something crappy that uses more RAM because it's just cheaper for you to do that, right?
Yeah.
So, for example, you're developing a game and you have, I don't know, 2 gig of assets, right? And you're just doing it, okay? But if you optimize your assets, if you kind of cut them into like atlases and so on, you could maybe minimize it to 1.6, okay? But it would cost you a month of development. Would you do that? Well, you wouldn't, right? Why would you do that? Why would you pay extra month or 2 months of work for no business value, right? If it doesn't translate into a business value, you don't do that, right?
Yeah, but even in places where it has business value, people don't do it. I mean, Android Studio generates what, 1,000 files when they create an empty project?
Yes, that's true.
Yeah, that's broken.
So, yeah, we can investigate it under that umbrella, right? So this is a valid point. I don't know, right, all the answers, and there are reasons which might be trivial, might be sloppiness or, you know, bad practices which can be improved. So I don't know, right? It's good. Yeah. What else? Yeah.
Advertising and monetizing applications.
Yes, very good. We also had it last year. So this is a very good topic. Monetization and business models. Business models. Okay.
I saw a really interesting article about that, which talked about a company that was their sort of marketing scheme was that instead of showing instead of monetizing your users with advertisements, you would monetize them that while your application was in the background, you would like be doing data mining on like bitcoins, etc. So now you're draining their battery life instead.
That's right. Yeah, that's true. So there are different ways of monetizing, right? One weird one I've heard on the conference on Web Summit was, you know, most of you have free plans for text messages, right? You can have unlimited, like some don't, but some do, right? I don't, but some people have this unlimited plan for text messages, right? So how about you sell it to somebody else who would use your account to push, you know, advertisements to people, to your friends, right? So you have a free resource, which is an unlimited SMSs. Somebody needs a resource to push SMSs through. You just sell it, right? You benefit from it. It's like, whew. Okay. Yeah, but that is good, and there is, you know, that's a subtopic which we had was in the context of games. Some of it may go into the, you know, Simon's course, right? If it's like game specific. but it can be discussed in this course too. So monetization business models, especially if it's sort of in between cloud or multi-platform kind of thing, that is where this course fits in. Like if you, a lot of game studios are kind of doing that, right? It's sort of called cross-media campaigns, right? So, you know, you have, you have Frozen, the movie, right? But you also have the song comes with the movie, because in the radio you cannot show the movie, but you can play the song, which kind of, makes people remember about the movie. Then you have, a game, stupid or not stupid, related to the movie, right? And then you have some merchandise where you're actually making a lot of profits on, right? So you're kind of building this sort of cross-media enterprise which tries to target different groups for different purposes, right? Because why do they have merchandise? It's for the grandma to buy a toy for their granddaughter, right? So the merchandise sometimes is targeting the grandparents, right? The game is not for the grandparents, and the grandparents don't care about the movie that much or the song, but they care about the doll, right? Because they can buy it as a gift, right? So, they trying to monetize on the idea or on the IP across multiple, media, So we see that more and more. It becomes kind of a platform, right? You very rarely have just a movie or just a game, right? You have all the things kind of bundled up because they have some sort of value, and they're trying to see, okay, how we can get money from the kids, from their parents, from their grandparents, and blah, 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 right?
That's also because you're not selling sort of like the one product anymore, you're selling the concept.
That's right, exactly. Exactly. So we see that transition as well, right? It used to be that business models were all about the product, but the kind of these days you're trying to make the product being something very intangible. It's an idea or an intellectual property or a brand, right? So like, the value of Apple is not in the hardware or software. It's the value of Apple is in the brand which they've built, right? And that's what you pay for. I mean, I'm not saying you paying for it, but the people who buy the equipment, right? So, and what is a brand? Well, what is it? Like, it's something that doesn't exist. It's very ephemeral, right? You may say, well, it is kind of a proxy to quality or a proxy to safety or proxy to something, but it's a very bad proxy. In most cases, it's not, right?
I would say it's sort of like an experience. So sort of like how, what's the really cheap flying company again? Is it
Ryanair?
Yeah, Ryanair.
Yeah.
They would actually design their web pages to be, really shit when ordering your tickets, just because then you felt that like you worked to get a really low price.
Yeah.
So their pages was designed to be shit.
Yeah.
From a Euro perspective, that it would be hard to figure out where you were supposed to go on the page, and how do you order tickets, and how much can you actually bring, etc. All of those were so that you felt that you had figured it out and sort of solved the puzzle, and therefore you deserved getting the cheap prices.
Yeah. Complicated. I also feel they're doing it a little bit too obscure of what you're actually paying for.
Yeah.
So it's kind of unclear, like you go to a normal airline and they say, oh yeah, you're paying that much, right? But here they say, oh yeah, you're paying that much. Oh yeah, you want the luggage? Well, now you're paying that much. Oh, you want this? You're paying that much, right? So it's this sort of diversification by obscurity a little bit as well. But it's, that's, monetization and business models definitely fit in.
How about sort of like being open to different level people? So like usability, displaying text.
Yeah, so that's...
Isn't that regulation coming in on that now? That like certain apps, etc., have to be approachable for people with different.
Yeah.
It's also universal.
Universal design.
Yeah.
Yeah, so that is a kind of an interesting topic as well, right? So universal design, and mobiles have that guideline as well. So when you're developing a mobile app, for example, you have Google and Apple telling you what to do, so then blind people can use it if it is possible to use that particular app. Like, I mean, if it's a computer game, maybe the blind people cannot really play it, right? But if it's a utility app, buying tickets or something, then maybe the blind people can use it. They just need to hear what the labels are for certain buttons and certain things, right? So you can add that in. And it's the same with people with limited sight or with hearing disability, right? So if you're relying on some notifications being audible pop-ups, then maybe you have to do it visually, right? So there is, of course, there are guidelines, and in Norway they are trying to force websites and web applications to follow the guidelines under the universal design, such that a wide range of people, colorblind, deaf, blind, can kind of use the public services, right? Which makes perfect sense. Like, if you're doing something for general population, of course, you should target everybody, right? But when you're developing a game, should you really focus on the game being playable by a blind person? And it's like,
no, but you can probably not mix red and green.
Exactly, exactly. So if you're developing a game, maybe you can make it more playable by a colorblind, right? The question though is, like, if you a commercial company doing something, right? So you see that with games, okay? There is a big studio, they have a game, right? All the games, not all the games are localized to Norwegian, right? Norwegian is like 4 million people. To localize something properly, you have to spend a budget, and the company is saying, okay, should we really localize it to Norwegian, or is the cost not worth the value which we will have from the Norwegian population? Because if we do that, how much we will increase the number of players, right? And the answer is almost nothing, because the Norwegian population is so well equipped in English that they will use the English version if there is no Norwegian version. It will not stop them playing the game, right? So, yeah, exactly. So then, the question, and similar question is here, right? If I'm a commercial developer and I'm developing a game, I have to make an effort to make it playable by colorblind people. How many players will I have? Is it worth doing it, right? I mean, apart from the ethical decision, there is also the business decision. And often the business decision trumps the ethical decisions and saying, well, okay, we're gonna screw the colorblind people, right? Unfortunately, right? Because it's too costly. If it's the public service, the answer is clear, okay? You are trying to do a service for your general population, it has to be accessible by general population. But if you're doing a commercial product, it's a little bit harder to enforce those rules, right?
You could add it as DLC, paid DLC, or you could drop it in loot boxes, and then it would be okay.
Yeah, that's true. So I don't know. I don't know like what the answer is. I mean, there is this big movement for universal design, but yeah. So I personally feel sometimes it's broken if you do it this way. Okay. So there are two ways of doing this. So one way is, so you have you have some sort of idea or something that will turn up to be a product, okay? And here you have your population, and the population is kind of, let's say, grouped into some disabilities or whatever, right? And now the proponents of universal design are trying to do is to say, well, you should sort of follow a process that tries to have something uniform for all of those, right?
It doesn't work for anyone.
But by the very definition of doing that, this is suboptimal, right? If you make, not always, right? But most of the time it is, right? If you make something usable by colorblind people and normal vision people, then the normal vision people may say, well, we could have this red thing here which would appeal to us more, right? So it is kind of suboptimal, right? So the alternative model is you don't do that. You say, okay, you try to target the groups and kind of localize it per group, right? So for the colorblind, you really have a proper colorblind version. For the normal vision people, you have the version which they really appreciate, right? Which one is harder? Is the previous model cheaper or better than this one? I don't know. I mean, sometimes it isn't, right? Sometimes this model is better, right? So you know, pushing a universal design for everything always, I don't think that's the good way of doing it, right? If I have to have something that is being accessible by blind and deaf, right, people, I really have to think differently for those two groups of users, right? I cannot make a universal design app for both of those groups. For the blind, I really have to focus on audio and the kind of the audio interface. For the deaf, you know, there is no audio, it's all visual, right? So, you know, universal design is not a solution for everything. It's a good practice sometimes, and for like web apps, it might be a way to do it, but yeah.
So instead of saying universal design, then I think it should rather say like design for differently abled or whatever the term is, because I'm not necessarily thinking of universal design.
So maybe differentiated design, designs, right? Yeah. Good. What else? Let's put one more. What else do you think?
Ethics regarding stuff like kids buying like loot boxes, essentially.
Yeah.
It always pops up in news from time to time.
So would you feel the ethics is the top level, or like, for example, ethics is part of is part of the business models? Could be.
You could also sort of add in one more and say, how do you like optimize for that? How do you get as many children as possible to use their parents' money?
Yeah. I mean, you could use ethics and the reverse of ethics to do that, right? So it is relevant to business models and monetization for sure. You could have ethics dealt here as well, because, you know, what is the ethical disclosure or ethical hacking, right? You could deal with that. Yeah. Where would you fit augmented reality? If you were to put a paper about augmented reality, which category that would fit? Could fit into all, right? But if you were to talk about it from the technology point of view, but if you
UI, UX.
Yeah.
I mean,
Yeah.
that's what I feel is most challenging with making anything for.
Okay, that's fine. Drones.
Scalability. Because that's actually a limited platform. We had over the summer, at our job we had visit from some drone guys. I think it was Crystal Dynamics or something that they're called. They're making these drones that are like this, that the military use, that are this small and weigh like less than 3 grams.
All right.
Or less than 3 kilograms or something.
Yeah.
Yeah, it's quite insane, and you can't see them from a distance. So we would like start them up and like hover right in front of us, and then move like 5 meters away and like 5 meters away and like 2 feet up or something. And you couldn't see it anymore, and you couldn't hear it either. And like that's
scary.
That's challenging and for scalability and performance and limited resources, etc.
Yeah. So that fits. So that's good. That means our list is kind of good so far, right? Games, well, again, depends, right? It can fit in one of those technology topics or maybe monetization, right? Blockchain can fit under scalability, definitely. Do you know about Ethereum, like the computing platform, universal computing platform? Where would it fit?
Like you're thinking about the new cryptocurrency, or
No, that just as a computing platform. Instead of using like Amazon and deploying something there, you actually deploy your smart contract on the Ethereum, right? So or IPFS as a sort of a distributed storage, right? So maybe we put that. So you could look into blockchains from scalability and performance point of view, but you could look, into them like blockchain distributed ledger, global computing platform like Ethereum or IPFS. Do you know what IPFS is? So IPFS, it's like Google Drive, but done by people who are like torrent nodes, okay? So you run a piece of software and you become a part of a distributed global disk space where nobody can delete things, but everybody can put stuff in, right? And you only host what you want to host, like from your own end, right? So if you put a file in there, the file will be hashed. The hash is going to be distributed around, and if anybody else needs that file, they will make a copy of that file on their local computer, and they will become a duplicate version of the file that you have. So it's non-changeable. It's sort of like Git, because you have everything versioned by the hash of the content, right? So let's say you want to use it for file sharing, right? You have a movie, you recorded some movie on GoPro, and you want to share it with friends, right? What you can do? Well, you can use YouTube, or you can put it on Google Drive and then share it, but those are proprietary platforms, right? This one is not owned by anybody, right? And it's censorship resistant, it's free, and it's available, right? So what you do is you put the file on your local drive, and you give a hash to your friend, and the friend using IPFS says, I want to see that movie. So he says, okay, I want the file with that hash. So then the network finds where is the nearest nodes which have that file, and kind of transmit that file to him, right? And if you're using LAN, like if you give it to somebody here in this room, the file from your laptop will be directly transmitted to another machine, peer-to-peer, right? So you don't have to go through central server, like in Google case, but it's kind of peer-to-peer. And then if you have a copy and he has the copy and somebody else needs it, then you have already two nodes which can share it, right? So for content delivery, it kind of makes things much more streamlined, and it balances itself, right? So the first person who gets it in US becomes kind of a node for the local environment, and other people can get it locally from US, right? They don't have to get it from you anymore. And the guarantee that they're getting a proper content is because it's always hashed, right? So you can check, okay, I'm getting the legitimate content, right? So you can use it for file sharing, you can use it for web apps. Like currently, if you want to have a web app, you have to develop a client side, and you have to host it somewhere. You need to have some sort of server which serves that client side app, right? So who runs that node? Well, you can use it on Amazon or whatever, or you can use it on your laptop, but you kind of a bottleneck, right? If you put it into the IPFS, suddenly anybody who wants the copy becomes a kind of a delivery network, right? So it is kind of like a torrent, right?
How does that then work with sort of piracy issues?
Yeah, it works very well with piracy issues. Yeah.
Like since now you're sort of like you're not just downloading stuff, you're like helping others. Well, I guess you already did that with torrent technology.
Yeah, you did that with torrent, and you don't.
But couldn't you choose not to do that?
Yes, you can choose not to do that, right?
And you can also do that with IPFS. So you can choose to just download and not be like a relay, or.
Well, if you downloaded it, you became a relay. But if you haven't downloaded it, you're not a relay for things you don't want to relay.
But that means that if you download something, you're also sort of basically also okay with sort of sharing that on. So if you're
that's right.
If you're downloading pirated music, then you also sort of become an uploader of that pirated music.
That's correct. Yeah. Unless you decide, okay, I'm opting out, and you delete it. Yeah. So once because it's sort of like Google Drive. What you have there is shared. If you delete it from your local copy, you're not sharing it anymore, right? So it's up to you. So you can sort of opt out, even if you downloaded something, to kind of delete it. But what you have in the IPFS drive is sort of, you become a relay for it. They have a privacy layer, so you may not know what you are relaying as well, right? In which case, you may be relaying things that you don't download it per se, and you are not liable for illegal things because you don't know what it is. It's all encrypted, right? So you may have a layer which sort of obfuscates of what people are relaying to a point where nobody knows, right? Which begs ethical questions and legal questions, and it's kind of really interesting from a legal point of view because, you know, you may have content which is perfectly legal in Norway, right? You may have content about Chinese government which you can host and it's perfectly legal here. It's illegal in China, right? So then what happens, you know? Nothing happens, right? Because you're free to do that. You're not breaking any Norwegian laws and you're doing it. And then all Chinese people can access it, but they are not relaying it. So, you know, it kind of sort of is legal to do something that is illegal in some jurisdiction, right? And there is no way for the Chinese government to force everybody in the world to delete something that is illegal only in China, right? So there is no kind of global jurisdiction control. So that's an interesting case. The other interesting case is, okay, pedophiles can use it to exchange materials, right? So then you may feel, okay, I don't want to be part of that, right? But how would you stop that, right? We don't know yet, right? There is no mechanisms to stop that, or, you know, law enforcement say, okay, these particular files are illegal for whatever reasons, right? Maybe pedophiles or whatever, right? Then maybe there is a mechanism for having like a blacklist, and you can opt in to have your client remove all the content that is blacklisted. So it's a form of censorship, right? You have kind of a list of censored materials, and you may opt in to say, I don't want to be relaying anything which is on that list, right? But that's not implemented yet, right? So that, you know, that there are discussions about how to deal with cases like this, okay? But it's a kind of an interesting topic in the distributed computing space, right? Okay, so I think we are more or less bulletproof in terms of topics, right? So now what we need is some challenging positions about things within those topics, right? So we need some concepts or ideas saying, I want to talk about, let's say, IPFS and kind of discuss pros and cons of certain things. So I want to discuss performance on mobile apps, why they consuming so much battery, right? And do some investigations, right? So we need some topics, but we cannot discuss them in a void. We need sort of evidence supporting things, right? So let's say PMS wants to discuss the memory usage on mobile apps and why the Twitter and Facebook apps are so big, right? But he needs to find some evidence or some papers discussing it. Otherwise, you know, you can't really do a case, right? So I will like you all for next week to think what would be the 3 topics that you would like to discuss, and find some papers where you put those papers under the headings for the stuff that we have on the wiki, right? So I will save it. I will say global topic list. If you came up with something that is not on the list, right? So you say, oh yeah, I would like to discuss this, and it sort of doesn't fit under any of those categories, just add a category, okay? Make things up. And then add papers as bullet points under the categories. And you can change your mind, right? You don't have to lock yourself to a particular topic or lock yourself to a particular idea that you want to discuss. You can change your mind after you read 1 or 2 papers, right? So PMS wants to do, just for sake of argument, wants to do this memory thing. He reads 2 papers and says, actually, I don't want to do this memory thing anymore, right? That's fine. So we will have the papers here and he picks something else, okay? What we will have next week is a list of papers for different topics that people can read, right? I expect you to read you know, at least 2-3 papers per topic that you will discuss, which means if you are discussing 3 topics, you have to read, you know, 10 papers, okay? And then when you're counter-arguing or referring somebody else's work and it's not overlapping with yours, you have to read some papers from that other work as well, right? So in total, you might read about 15 papers for the course, okay? Which is similar to the game course. In the game course, you will be given papers to read each week. I don't remember, we have about 12 weeks or something like this. So we will read about 12-15 papers for the game course to those of you who are doing both. Here it's similar, right? Some of the papers which we use are not very long scientific papers. Some are just sort of well-structured blog posts, because I will put some papers under those topics too, right? Especially the ones which I want to demonstrate some of the faults of wrong argumentation, right? So if you read a little bit more papers in this course, that's fine, because they're generally a little bit shorter than the ones in the game. But what will happen is next week we're gonna discuss the papers, right? No, we're not gonna discuss the papers. We will have the papers, we're gonna discuss the topics, okay? Because formulating a topic is one of the challenges which we will address in this course, right? So we will spend a lecture, not the whole lecture, but a little bit of time, me discussing what is a good or bad topic, and we will have a discussion about it, okay? And we will have a list of papers that people can see and read, okay? So you can start sort of making your mind, okay, I would like to discuss this, this, and this, and I need to read a little bit about those topics, and then you will formulate the topic. And we will kind of, before you start writing about it, we will refine the topic itself. Okay, what can go wrong with the topic, why the topic is good or why the topic is bad, what is a well-formulated one and what is sort of an ill-formulated one, okay? So spend some time discussing the topics for next week. So bring in your head the topics that you might want to put forward. So if each of you will make 3 topics, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we will have 30 topics in general, right? It's a lot. So what we may do, we may have more than one person doing the same topic, right? Because then it's sort of less. I will talk about the logistics next week, right? Because we have to have this kind of big matrix of topics, the essays that everybody will do for, and then people have to be mapped to reviews and to counter arguments, right? If we have 30 topics in general and only 10 people, then the matrix is not, it's quite sparse, right? So there will be holes. So we have to make the matrix kind of as dense as possible, so then we have a small number of holes, right? Because if you have a topic and nobody reviewed it, that you will feel, it sucks a little bit. So it's kind of good if the matrix is kind of more condensed. So we will do it next week. So you know what to do? Papers. So how do you search for papers? Google Scholar. What else? Yeah, you can use Google as well, right? So you can use Google Scholar for papers, but you can also use Google to get some sort of a feel of the terms to be used and who are the people working in it. You can use Google to find some labs which lead you to people web pages with a lot of papers. So you can do it this way. There is a lot of library resources for Web of Science and kind of indexing databases where you can do searches on papers as well. Very good is to do a reverse search on the references of the paper that you found, right? Let's say you go to Google Scholar and you found one paper. It will usually have about 30 references at the back. That's great, right? Check them, right? Check if some titles or some of the content of the paper interests you, so then you can go to the paper from the references, right? You can also notice that if you have a paper with references, you can see proceedings of a conference, right? That's great. Go to a web page of that conference, and you will have a list of other people being in that conference and discussing things, right? So let's say you want to do something with UI. You found one paper about mobile UI. You go to the back to the references, and you see a number of references citing, you know, Kai conference, right? Great. So go there, check what they are doing. Yeah, you know that this one. Kai conferences for user computer human interaction is the most prestigious kind of conference in the UI UX space. Why you have to do this? Why I'm forcing you to do that instead of like Simon giving you the papers? Well, it's a skill that will come really handy when you're writing your master thesis, right? When you have your master topic and you're writing your master thesis, nobody is gonna give you the list of papers, and you will have to have probably about 70 or 100, right? Out of which you will select about 30, 40, 50 for your references for the thesis, right? It's a lot of work, and you know, if you're doing it for the first time for your master thesis, that's not too good. You will see some shortcuts and some techniques here that you can then reuse, okay? And we will share how people are finding. I can tell you how I'm finding papers, but you can tell me how you're finding it, and maybe we can learn from each other, right? Okay, how many papers should you find? Well, that's tricky, okay? So the rule of thumb is that if you have 3 valuable good papers per essay, that's fine. No, not more than 3, okay? Sometimes 2 is enough, okay? But how do you get those 3? That's, you know, that's tricky, right? Sometimes you are lucky and you find 4 or 5 papers out of which 3 are great, and you use those 3, right? But sometimes you have to find like 2 or 3 out of which you find some references, and you kind of do like a depth search, and then you get to something that is really good, right? There is no kind of algorithm. There are some heuristics, right? So read the abstract. If the abstract sounds relevant, continue. If the abstract doesn't sound relevant, stop, right? You know, try something else. Of course, you're starting with the title, right? But sometimes title is not enough. Sometimes you do have to read an abstract, okay? The title may not sound relevant, or may sound relevant, but it's not. But you know, it's better just to read an abstract. Abstract is usually a paragraph. It's not a lot of effort. You know, it will take you a minute or 2, and you will know, okay, is it worth reading the paper or not? If the paper is written by the author that you know is relevant for your work, if there is someone doing work in memory management and he publishes something, reading the title may not tell you, but reading the abstract will tell you, and then you can be biased in favor of somebody that you know, right? So if it's someone you don't know, then be more critical, more skeptical. But if it's someone you know, then maybe it's worth reading that paper anyway. Maybe the paper is relevant, maybe not, but reading a paper is probably worth your time, okay? There is literally millions of papers. There is not possible for you to read even a substantial chunk of it, right? You will not be able to search the space by reading stuff very exhaustively. You have to be quite smart in picking what you read and what you don't read, right? Again, it's a skill, and it's not something that I can tell you, okay, do it this way, and it will always work. It's very tricky to do that. And you will have to be doing it for a while for your master thesis, right? So here, don't go overboard, right? I would say if you spend more than like 45 minutes on a topic to find the relevant papers, then you probably reached your limit, okay? It doesn't mean that, so that 45 minutes is to pre-select a list of, say, 5 or 6 papers that you're gonna read. And then out of that, you will read the papers and pick 2 or 3, okay? Don't make the pre-selection list very long. Make it sort of 5 maybe, okay? And then you don't have to read all 5 papers, but you have to pick 3 out of the 5. So which papers do we want to be listed here? I would like the papers that you think are very likely to be helpful, right? So should be only the papers you've read. Yes, all the papers you've read and you think are valuable should be here, but you can also put a paper that you almost read, you read halfway through and you still think it's valuable, then put it here, right? So if you haven't completely read the whole paper, but you really are convinced that it is a relevant paper, put it here, right? But if you just read an abstract and you don't know, then don't put it here, right? Because that means, you know, there is extra work people would have to do. It's like 10 people would have to do the work than one person could do, right? We want the kind of go, no go decision. So if you decided, yeah, it's a good paper, it's a relevant paper, then you put it here, okay? If you find a particularly bad paper, right? If you find a paper that you see, oh, come on, you know, you cannot do this, right? Put it here as well, okay? Those are kind of fun to use sometimes, especially if you're doing a counter argument, okay, or something like this, right? All right, so any questions? So you're clear about the course? So the course is sort of, we're doing peer review as well, right? So you will be reviewing each other's work, each other's essays by doing those 2 reviews and counter. So the 6 things that you write will create a portfolio. And then you're gonna get a grade from that portfolio, plus there will be an oral exam at the end of the course, right? The grades are not peer given, so you will not grade each other, but you will kind of mark each other, right? So you're doing kind of a pre-grading, right? And we use that as a guideline as well for final portfolio marking. Can you fix things? Can you write your essay again? Well, we don't have time, right? So unfortunately, we have a limited time to do that. But what will happen is you will write your first essay first, then you will write some of the reviews and counters, and then you will get the feedback, and then you will do the second one and third one, right? So by the time you're doing your third one, you've already got a lot of feedback, right? So even though you may have done some things wrong for the first essay or first reviews, by the time you're doing your third one, you know, and we see that, right? We see people doing first, second, and the third is usually really good, right? So the grade is kind of for the third one, right? I'm not biased or I'm not really uniform. I'm actually grading you of what you've learned. So I'm kind of grading you on the last ones more. It doesn't mean you should make the first one shit, right? Try to do your best, okay? But it's usually a progression. And we've seen it last year with students that the third essays were really much more improved and better than the first essays, right? It's a natural kind of progression. So I think it's working fine. Right, if you have any questions or any issues, use the issue tracker. So we are having the wiki here, but we also have an issue tracker. So if you have questions or comments or suggestions, use it. I will use the announcements through Blackboard, but apart from announcements, I'm not gonna use Blackboard for anything in that course. We did try to use Blackboard last semester, and it's it's hard to use it effectively. So we think just using wiki and issue tracker in this course will be fine. We will have another tool for doing those essays. So I will show you the tool once I integrate the module which some of the students did last semester. I still haven't done that. And we use the tool to exchange the comments and the essays. The essays are just pure text, right? Sometimes we have a question, okay, should I use some graphics, some diagram for my essay? The answer is yes, you can do it if you want, but then you have to like link a PDF to the essay text because we don't have embeddable graphics in the tool. It's sort of really a discussion type of thing, right? So if you really want to include some graphics, you can do that, but then attach a PDF to the text that you put on the essay. We have Markdown, so you can format your document the way you want using Markdown, but no graphics. Is it a limitation? I don't think so, because the whole point here is about written argumentation, right? You can do argumenting by designing something, like saying, okay, this UI is better than that, and it's really hard to do in words, right? Then, of course, use graphics.
If we have Markdown, don't we then also have a link of images, etc.?
Yeah, you can have links to images, yes, that's right. So you can basically do that. You can embed like a figure, which is an external image. Yeah, that's fine. What else about this? Don't abuse the system. You know, the system is not bulletproof. It has vulnerabilities. So try not to, you know, destroy it. Yeah. And also the wiki and everything here is quite open, right? So if somebody asks a question and you know the answer, just answer them. You know, it's fine. It's for everybody to use. We kind of a group. It's not just me versus you kind of thing. If you have, you know, something to modify or add to the wiki, do that as well. I'm not 100% sure that the wiki is version controlled, but I believe so on GitLab. I will double check.
Okay. Okay, guys, half an hour attention, then we are all off. And I need you a bit more, and then afterwards you can just go home and don't need to go to graphics. Mobile programming. I promise you. Obviously, that's not true. You probably need to go there. So, so it's another 2 hours of listening. But anyway, so now we want to get a bit closer towards programming, or at least understanding the code that you wrote already or had to deal with at this stage. And again, I want to get that mechanics out of our way. So, apart from knowing about the pipeline, we obviously want to program it. And so a few things that we need to know is about OpenGL as a language, some of the concepts, the data types involved, and how functions look like, and so on. So yeah, let's go right into it. So again, in general, one of the key or core concepts that we're using or have been using quite intuitively is a vertex, which is basically generally just the coordinates, or conventionally it's the location of it. But it can also be colors or texture coordinates or whatever else. So something we explore later. The point is there, vertex is a kind of a generic or quite general data structure that you can use in different contexts. So don't be confused if you see it popping up in different concepts. Generally,
I'm pretty sure on GitHub it is.
Yeah, GitHub.
I think it should be here too. Yeah, what else? We have a Discord channel as well for chatting with master students. So you can use it if you. I think I've posted the invite link, but it expires. So if you want to join and it expired, you can just send me put me an issue in the issue tracker, right? Yeah. All right. So that's it for today. Unless there are some questions.
3- and 4-dimensional vector representations that we're dealing with in OpenGL. We get to the reason for that one later on. You can pretty much use any coordinate system of your choice as long as it's consistent, right, between all the individual models in the scene. But for clipping purposes, meaning for displaying purposes, again, it will only be rendered within that range of -1 to 1 for the x-axis, y-axis, and so on, right? So we talked about this briefly before. So now it becomes a bit more messy, or let's say a bit more OpenGL-y, in a sense that vertices are generally stored, or rather referenced by vertex buffer objects, as they're called in OpenGL. And it doesn't matter whether used or not, it's just the base information that can serve as input for your programming, for your pipeline execution eventually. Those virtual buffer objects are then organized by vertex array objects that allow them to actually introduce them for the use by shaders. So, and the idea there is quite straightforward. We'll explore that in a bit. Just wanted, before we do that, want to go into some of the data types here that are available in OpenGL. And similar to the functions, they have the prefix GL, so that's how you differentiate them from C++ data types, for example, right? So everything starting with a GL. So slightly different representation. For you as a programmer in C++ doesn't make much of a difference. You can't obviously pass an GL float into a conventional float, that won't work, but you can pass it into the corresponding OpenGL functions, which likewise start with GL. You figured that out already as part of the lab, right? So those are the data types we're dealing with. Any surprises there? Hopefully not. So now a word of warning before we do more code. Sometimes on the web, and that's usually a good indicator where you should stop looking, you find that kind of code here, right? So you're creating a new list of vertices. You're beginning it, you want to render it ultimately as triangles, and then you specify the individual vertices, finish up that list, and have it ready, right? This is the old syntax. So if you see that kind of stuff, you GL vertex 3f and so on, this way of specifying it, that's generally means you are in a tutorial which is a bit old. You may not want to continue looking at this. Just a word of warning, because it's super easy to fall into that bracket. So, but instead, for the programmable pipeline, we do it slightly different. So first of all, thinking about the pipeline is pretty much a state machine, right? So you produce or you generate input, or you prepare the input rather, attach it to the vertex processing of the OpenGL pipeline, and you basically pretty much just execute it and can reference and modify that state. It's kind of you can't have multiple instances of the pipeline, for example, but the advantage is that you don't need to reference to any particular shader object or subsystem or whatever else. You can directly operate on it using GL commands, which makes it quite convenient. But if you switch to that mode of thinking, it's actually quite straightforward to dealing with this. We have sequential execution. We may have side effects, meaning it makes you affect other parts of the pipeline or your data and so on. And as I mentioned before, the important thing is to realize that any output is basically or the previous stage is input for the subsequent one, right? So you have a filtering effect here that you actually continuously reduce certain a set of vertices that you want to render or print, for example. Cool. One term I want to get about or finish up on as well is double buffering. You guys who knows double buffering, did you learn it elsewhere? You guys are all reasonably, you actually don't need those lectures because you know more about those things anyway. Please. What?
Yeah, I know.
Yes, you know double buffering. Do you want to explore the intuition, even though it's on the board here? It's actually on the board.
Well, it's more like they have two buffers.
Yep.
They can swap off.
Yep. Cool.
And draw.
Yeah. What's the purpose?
You draw to something that's not the same.
Yep.
Get a more consistent frame rate, or
That's another point. Yes.
for example,
Yep.
VSync, that you make sure that you have really tight intervals where the frames arrive to the it doesn't vary that much based on the load.
Okay, that's a really good point here. So you can actually control the frame rate, right? Because by swapping buffers more or less intentionally, you can also systematically reduce frame rate if you need to or want to, right? So that's a good point. I didn't think about this too much, but rather the idea is that while you're drawing, in worst case, you're still rendering your individual pixels, right, for the output, and you don't want them, or you don't want your partial printout being displayed on the screen yet, right? So, for example, the screen updates is not in sync with your OpenGL processing, and suddenly you have half of the screen rendered, half of it is not rendered, so you have weird artifacts or some sort of tearing and so on, which you know from TVs anyway. This interlaced. If you do a digital recording of CRT screen, for example, you see that interlacing effect. Yep, please.
And I want to add that.
Yep.
If you finish early
Yep.
computing
Yep.
the next frame, you can start on the next frame. You don't have to wait for the swap because you have an additional buffer.
Yeah, we get to that. That would be the triple buffering element. Yeah, you're on the right track.
I mean the triple buffering.
Okay,
sorry.
good.
Yeah.
So, so the idea of double buffering is we have one foreground buffer, one background buffer, right? Same size and same purpose. They are representing the entire screen, right? So screen output, and you're rendering to the back one while the front one is still displaying. It's the old image, right? So once you're done with this one, you swap, and now you're writing to the back buffer in preparation for this next subsequent image or frame, rather. And the previously developed one or generated one is actually currently displayed, right? And you swap again. So that's double buffering. The continuous swapping. The idea there is, okay, how can we improve performance further? The issue is that during the swapping, there's no writing, right? So both buffers are busy. One of them is swapped to the foreground, the other one to the background. So the GPU can't write. Wasted time, right? GPU cycles wasted. The idea here is to use triple buffering. So you have a third buffer that is actually written to, so to alleviate this delay that is caused by this actual swapping, right? You have a third buffer that you're actually writing to, and then you're displaying this one, and the other one can be written to while the other ones are written and swapped, and so on. So you get a performance advantage there. So you can continue, as you said before actually continuing the swapping, you can continue rendering already on the third buffer. Third buffer. Therefore, triple buffering. But the only thing is, why is it relevant for us? Because you will constantly need to swap windows. So it really depends on the. I probably should have put a brief excerpt of the APIs, how they do it, but this is done by the GUI, those utility frameworks basically, like SDL in our case, ULFW, or whatever else you want to use, or Glue, which we didn't talk about. I'll refer to them in the next session. They will need to do that, right? It's not something that's done by OpenGL. That's actually you are saying, okay, or that framework is saying, well, now it's time to actually swap the buffers. That's why you will constantly need to call that if you want to actually update your image. So much about this. I just wanted to lose a few words on this so everyone is on the same page. So looking at the pipeline, getting closer to it. So initially when using the pipeline, you saw that in our code. If you did the first lab, there should be a lot of things coming up, and you see the pattern here. You initialize the OpenGL instance or version you're dealing with, right? So whether you have a compatibility profile or the code profile, you may have seen that the version, major, minor version, you want to have initialized on your for input, and then you organizing the input, having some input buffer, and actually filling this. We get to that. Then you obviously plug in some shaders, which was implicit in the first lab. Again, we do that next week. Have a look at this, which are basically uploaded to the GPU. And in fact, this is uploaded to the GPU as well. And then finally, you actually draw whatever has been input there and is operated on based on shaders will actually be drawn. And you afterwards detach from the inputs. So you can have various inputs that are rendered to the screen. For example, you have, think about it, so this is your screen, and you can have potentially, here's the pipeline. You could have potentially different buffers feeding into the screen for processing. Between different frames, you use different information. For example, this one has position information, this one has texture information, the third one has color information. So it's really up to you how you do it. That's why you basically activate an input buffer. For example, this one here, for the actual processing. You do the processing, you deactivate it afterwards, and for example, this one is activated and processing is done. That's why you have an explicit reference to the deactivation of the input. We get to that in code in a second. And afterwards, you obviously need to swap the window. So here's SDL, the framework of choice, and that actually moves whatever picture has been rendered into the foreground, right? So then the back buffer is available to be filled again with further information. All right. So how does it actually work? So at the core of it is what is called the vertex area object. And this is kind of ties up everything that we are dealing with. Do you have anything for removing? Okay. All right. So vertex area object has some sort of index. Further parameters, I fill them up once we get there. It probably makes a bit more sense. And then here, 0 is more appropriate. Endpoints. To buffer objects. So let's do it this way. We have so let's assume that this base buffer object basically represents a set of vertices. In fact, 2 vertices of 3 dimensions, right? So we have x, y, z. We have x, y, and z, right? So we have 2 vertices represented here. So it's not quite a triangle, but we could make a line out of it, whatever else we want, right? So, and the vertex array object, or VAO, as you'll find in most references, has some sort of identifier that's registered in the pipeline processing. So when it's generated, and which basically then links to the appropriate buffer. And we see the parameter that it uses to fill it up in a very second. And the first thing we basically do here is to generate this overall vertex array object with reference to specific entries that are available that point to vertex buffer objects afterwards. And the functions you're using to do this is GL gen vertex arrays and GL bind vertex array afterwards. The idea is there you have some sort of identifier that you refer to when you generate a given number of arrays, right? So we only generate 1 right now, but you can generate up to, depends on the implementation, generally, anyone? Any number in mind? I think 16 is the conventional implementation, but it depends. You can ask the context constant, I think it's called GL maxVO or something like that. It will actually display the maximum supported inputs you can generate. Cool. So we only generate 1 here right now, and afterwards we actually bind it for use. We tell the system, okay, this will now be available for use for potential rendering-ish, right? At this stage, however, there's no reference to any underlying data structure yet. It's just generating this entry there, right? Which is at the core of the processing pipeline. At the next stage, we're generating the vertex buffer object. And this is, in my simple representation right now, this thing down here. So it's a buffer object. We again have a number of them that we have. We need to have a reference to them. And again, we bind them to the actual pipeline, right? We can generate them, doesn't mean they're actually bound for use. Same pattern here. So identifier generation, we only create 1 of them. We do it by reference. Then we'll bind the buffer, and we bind it to the GL array buffer. The point is, in OpenGL, there are various buffers for different purposes. For example, for color buffer, texture buffers, and so on. But we're just interested in the rendering, which is the GL array buffer. So meaning any input that's somewhat produced here will be uploaded to the this buffer and thus subsequently displayed as part of the display. I moved my beautiful rendering environment. Please.
When you generate the buffer,
yep,
isn't it already on the GPU? Like,
yes, yeah, it's already on the GPU.
It's a bit misleading that the comment there where it says upload the data from CPU to GPU because
that's right,
it's already
that's right.
there.
That's right. It's basically a comment that I blindly overtook. You're right.
Yes.
Yes.
And the bind, that's the way I understood it, is sort of like activate you. You say
right.
This is the active one.
Yeah.
If you bind again, it changes the active. So
that's right.
The one who was bound is no longer
unbound.
bound.
Yes, that's
you
right.
You can only have 1 buffer
bound
at a time.
That's correct. Yes.
You have many buffers.
That's right. So if you have many buffers, that's what I meant before. So you can basically swap between them. We get to that as well. There is advantages and disadvantages to them. So obviously the binding and unbinding process takes considerable time. So there's one other way you can deal with this by basically having vertex, some input. For example, if you want to represent vertex and color, you can basically interleave them this way. Z, right? So you don't necessarily only need to have a uniform representation of a particular, within a particular vertex buffer, but you can have interleaf information. For example, you're only interested in the position right now, or only interested in the color, so you work with offsets within the buffer, but use fundamentally the same buffer, so you don't have the overhead of binding and unbinding and rebinding a different buffer object. Yeah. So, but we get to that in a second. As usual, you guys are a bit ahead.
1 second.
Yep.
First, are you supposed to be streaming to GTL now, or are you recording? Because on GTL YouTube it says it's a graphics like this lecture, but Mario's just lecturing on something else.
Then he hocked my stream. I'm actually streaming to it.
Okay. Are you recording as well, or just?
No,
Shit.
I'm not recording it. But he's probably now doing. I suspect he will not be recording right now. He's probably just setting it up and is perhaps moderately.
No, it looks like he's talking to a bunch of people.
It's our class. We're having like 15 minutes together, right? Anyway, bad luck. So suggestion: attend that class. Probably I need to come up with a new channel. I have my own.
Yeah, maybe have separate ones.
Yeah,
that would be.
Yeah, screw that. Doesn't work.
We don't have the channel in the global school.
That's right. That's right. Yeah, we share a channel which is kind of semi-stupid yet okay.
Shared variables.
That's right. That's right. Yeah, we're fairly unorganized in that respect. Okay. Yes. Yeah, I shall fix that kind of issue. Cool. All right. So we have those two things: vertex area object, buffer object. And since before we're running out of time, I want to finish up that thought. So we obviously need to fill that somewhat, right? So we need to fill the buffer with vertices. Here right now I did the shortcut and said, well, you know, that's the vertex buffer object and has all the stuff in it already, but it's obviously not the case. In fact, it's filled by with some sort of input data, right? So an array of x, y, and z coordinates, for example, right? So it's something like you guys did as part of the first lab. Hang on. RGB. So that's pretty much the input you're getting. So that is where we're still on CPU level first, because that's actually coming from C++, right? So it's the input data you're actually consuming. And you need to indicate, so that's the function we're using, and this would be basically the input XYZ, XYZ. We need to say what we're actually pointing to. So we're pointing to the array buffer that's responsible for the display output. We are referencing obviously the data I want to put in their size and what kind of drawing it is. It tells the system whether it expects frequently updated data or rather static data, meaning it doesn't actually need to do lookups anymore, or it doesn't need to update data coming from the vertices input because it's only printed once, for example. But we see that later on. More importantly, is the vertex attribute pointer, because this kind of explains the semantics of, or rather the syntax or structure of the input data that we're getting. As I mentioned before, so one of the things is what's the layout identifier in the shader later on. So that's super important for later processing. I will re-emphasize that in a second again, because that will be relevant for next week. Because this is just the entry point of the pipeline, right? But further down the track, I'm not sure if anyone sees any stream here, but I will pretend I care for the streaming people. So recall that this is basically the input, and let's say we have the vertex shader here, we need to be able to reference the input we're basically getting, right, in the vertex shader further one stage down here, because what this basically does is linking it to the vertex area object, which may have an arbitrary number of entries, but we actually need to tell the shader which ones of those to consume eventually. And this is precisely that identifier, the location identifier that we'll be dealing with. So then we need to have the size. What's a generic, what's the number of components that represent one vertex, right? So in this case, we're saying it's 3, x, y, z, right? But we could have a fourth dimension, for example, or we could have color information as well. So if we had RGB here, so suddenly we would have a size of 6, right, for one element. Does that make sense? Good. What else do we have? What's the data type? Surprise, surprise. In this case, it's float, right? So it could also be integer, unsigned integer, and so on. do we want to normalize some data? So meaning it basically explores the depth range of available data, so the data range, and compresses the data within that range. So for example, if you're, we do it later on when we get to that, makes more sense. So basically, but by default, you would say no, meaning don't manipulate any of my data, right? So no internal manipulation at this stage. And then there is the idea of the concept of the strike. And here, again, it looks at the structure of the data, because if you, for example, use the same input buffer here, but want to use it for different locations in the vertex area object, you can do so. So let's say if I change that here, point to that one down here. One of the parameters we're dealing with, for example, is strike here. We get into that one. So we have size, for example. So let's work on this particular example. We have a we want to, for example, in buffer 0, we want to represent only the XYZ coordinates, so the 3 coordinates. So the size will be 3. What else do we have? I will only concentrate on the relevant elements. So we have the index, we have the strides, we have, we need to have the strides. And the strides is basically indicate the space between individual generic vertex components. So, and if we had if we wanted only to represent the vertex coordinate x, y, and z, we don't care about color. But unfortunately, our object here, vertex buffer object, includes also color information. The stride indicates the space between each generic vertex component. And in our case, it would mean we have gaps of 3 between each of the vertices in the array. Yeah. So we would have a stride of 3 here. And the other important thing is the offset. Where do we actually start processing the triangle? Here we're interested in vertex information, so our offset would be 0. We're starting from the first position, right? But if we do the same one for this one, assume we want to represent only color. Similarly, so our element size is 3, so always 3 components. The stride between is also 3, but we're dealing with an offset of 2, right? Get it right. So, cool. That makes sense. 3. So meaning the idea here is, this is quite powerful. You need to get that right. You need to identify, okay, what constitutes a vertex or something I want to process. Doesn't need to be a vertex just to get that right. You can also process a vertex plus color plus texture information in one go and see that as your unique, you know, data unit, if you like, right? Because in the end, you need to deal with that code anyway. In the vertex shader, you get all that as input, and you need to work on that, right? So how you do it then depends totally how you implement your vertex shader later on. Again, remember this one will be the identifier, how you identify all that content in the vertex shader further down the track. Yeah? Is that somewhat clear what happened here? Or totally unclear? Or can someone fix my bugs here? My conceptual bugs. No harm though, because this code is basically stolen from the lab 1. So if you look at the lab 1 again, and you start playing with it, especially if you're not sure if you haven't done it yet, but the lab 1A kind of amendment, have a play with this one, you'll need to understand exactly that down there, right? Because so we're dealing with all those elements there. Cool, yeah, I just came up with an example. So assuming that we, for example, have strides, we're having, for example, vertex buffer and texture data in some sort of input buffer, and we have a data type of float. A float has 4 bytes. What's the stride size? Anyone? What's the size of the entire data, 1 unit of the entire data representation?
20. STY?
Yeah, exactly, right? So we have just 20 bytes basically represented. I simplified it over there, but that's the way you would represent it, exactly. So, coming back to our little pipeline exercise, so we now have the vertex array object that references data, and we have identified the structure to some extent in the data set. Now we want to actually draw it to the screen, right? So, and the idea is there, we need to enable a particular attribute arrow input. Happens to be that identifier there as well. So we say, okay, use that one, whatever is in there, with all the structural specification that happens, for input for drawing. So we do this one. Then we actually call the draw function. So it means now draw it, right? Now, this parameter suggests the geometric shape you want to generate based on the vertex input you get, right? So we talked about it briefly last time, but the idea is there, if you have GL triangles, well, you need to have 3 vertices, right, that are shaped in some sort of, and you produce some sort of triangle out of this. Could also be GL points, GL line, and so on, some other ones of this. And this one is the offset you're starting from reading. So you may, for example, omit, the first 1 or 2 vertices if you want to, and what the number of vertices are you want to read, right? So in this case, for example, you only want to use the first, you have 20 vertices, you only want to use the first 5, you can indicate it here, right? So the system will, or the rendering will only perform operate on the first 5 of those. It's always about having a buffer with data input that you ideally don't need to modify, but instead you're just modifying the references to that buffer, right? Either by having multiple indices, vertex array objects, or you're operating within the buffer directly. That's the alternative. Okay, following this one, you disable the input. That was what pretty much you were saying before. So now, for the next iteration, that's one loop iteration, we actually may want to use another vertex attribute array. So it may be, for example, the one with the index 1 for the next iteration. So then you do the drawing again, you deactivate it. So it always comes in a complementary execution. And then here is the double buffering, that's swapping the windows. Yeah, but this is not done by OpenGL natively, it's in fact done by STL. So it really depends what framework you use. If you're using GLFW, just find the corresponding function, do the swapping, and you're done. Right? So it's no biggie. That's for us not the main concern. But this is the aspect that's more important. Cool. Again, a pointer to that identifier there. So the geometric primitives that are all available, for example, are those ones, the more common ones. I think they're continuously extended in OpenGL to some extent, but those are some of the more general ones, because like triangles, you can use triangles to represent pretty much anything anyway. And you can just basically indicate whether you want to see points, line strips, line loops, triangle strips, and so on. There's a virtualization here as well. To represent that. You just want to show points, individual lines. If that's the case, then the vertices are interpreted in pairs of 2, and then lines are formed between those, so they're not connected. If you have a line strip, it will connect all the individual vertices. If you have a line loop, it actually will connect the last vertex with the first one as well, again. And it has, in fact, a similar effect like a polygon, which does the same thing, because the idea is, well, polygon is that it's a closed circuit of linked vertices anyway, right? Cool. So if you do run the GL triangles, it will take the first 3 vertices and make one triangle out of those, and the next one's another triangle, and so on. And yep, there's some.
What happens if the number of vertices you have is not divisible by 3?
Yeah, then you're kind of in trouble. It depends on the implementation, how it reacts, but generally that's precisely those things you want to figure out carefully. So try it out, it should break, more or less aggressively. Some implementations will capture that issue, but yeah.
You can also find this in 3D modeling, for example. Okay. If you have more vertices, or your vertices are not dividable by 3, you will have an impossible shape. Yeah. You will not be able to render this shape. Yeah. And you have to fix it before you can really do anything with it.
Yeah, you probably see just a background screen, nothing else, right? So I think that's the most, the general response in OpenGL. Did you try it?
I tried drawing triangles with 11 vertices, and it just skipped the last 2.
Oh, cool. So that's cool. Yep. Ah. So that's an easy way out. So And there may be different forms then, right? So if you have a triangle strip, it will take the last two vertices. So if we have 0, 1, 1, 2, so on, it will connect, start the legs, or align the next triangle, or extend the next triangle adjacent to those last two vertices, right? So you have vertex 1, 2, 3 forming the next triangle, 2 and 3 being the basis for the next triangle, 3 for the basis for the next triangle, and so on. That's considered a strip. And then if your fan idea, with the fan idea, it's always linking the last vertex and the very first vertex. So you have a fan structure emerging based on this one, or quadratic variants as well. I'm not sure if it's supported in our framework right now, because I was trying to draw it and wasn't really successful. Cool, but that's something you probably can explore a bit more. But it makes sense, right? No magic there? Cool, yeah, good. Final word on the game loop. So just to get that right, so when you want to execute and want to modify input and render new frame, the cycle is basically only the element of activating a particular attribute pointer, the input pointer from the vertex area object, doing the actual drawing using those geometric primitives, the activation of the attribute pointer, swapping the window to the background, to the foreground, potentially modifying the vertices if you want down here or not, and then a loop again, right? So that's the entire loop you deal with. The entire setup is done once when it's all tied up, like the mechanics of VAO, VBO, and the underlying data. Then you will just need to modify data and just indicate which of those input errors you actually want to, or attribute inputs you actually want to render to the screen, right? So meaning it's more like setup and parameterization, but afterwards it becomes a lot more feasible. So the game loop is effectively that bit here anyway, right? So you are activating some input, drawing it, deactivating it, swapping the window, activating the next input, and so on, yeah? Cool. So that was pretty much it for today. Just want to give you that overview. Is that somewhat clear? And if I would encourage you, especially if you want to reinforce it, have a look at the lab again, because it's exactly there in there. So it's pretty much near the code I took from there, but you find the same structure. But hopefully now it makes a bit more sense what's actually happening behind the scenes in terms of how the system is organized, that you have this index element, you have the buffers associated with this, the input data that feed into the buffer objects, and the activation of the corresponding entry. And this will be particularly important for later on, because here, again, this index will be one of the input parameters here, so you actually know which input data you're operating on for vertex shaders. I'm just saying that right now because you may just get a lab on Monday which deals with vertex shaders, and we actually didn't talk about it, but at least you have a starting point there. Plus we obviously will give you a brief primer on what's happening there, because of this interleaved lecture lab thing, right? Originally I intended to have a lecture ahead of the lab, which would be super cool, but I'm not sure how to fix it on the short term right now, because I want you guys to be as coding as quickly as possible, basically, so you guys can start doing stuff, and then I do the boring bits. Cool, right? So yeah, that next session we look at those two ones, vertex shaders and fragment shaders, how to program and use them. But for today, that's pretty much it. Thoughts, questions, worries? It's a bit of a long session, I know, but I admire your endurance. No? Some of you are still alive. Who's playing games here anyway? Sorry, you have a...
When are the projects?
We'll plan to hand them out after probably next Friday roughly. I want to give you the first assignment, so you know actually what to do. But then you'll also have the necessary functionality to actually do it, or most of it in fact, right? So all the rest you can figure out yourself. That's the keyboard handling, blah, 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 that stuff. But at least you have the mechanics, you can start thinking about the concepts. Right now it doesn't really make full sense yet, I think. But thanks for the reminder. So I have something to do for the weekend. No other concerns? Anyway, if you have questions next Monday, we'll probably have a mini session and you can ask some questions or raise some concerns about what we talked today. Cool, cheers. See you in about 15 minutes. Which room are we in?
Yes.